Welcome to the First Law of Thermodynamics for the CBSE and NIOS curriculum. It is the statement of conservation of energy for a thermodynamic system. In words, the change in internal energy of a system equals the heat added to the system plus the work done on the system. Mathematically, in differential form, we write du equals delta Q plus delta W. In finite form, we write delta U equals Q plus W. For only pressure volume work at constant external pressure. We will also use W equals minus P times delta V because expansion work is done by the system. CBSE and NIOS sign convention. Heat absorbed by the system is positive Q. Heat released by the system is negative Q. Work done by the system, like expansion, is negative W in this convention. Work done on the system, like compression, is positive W. So we keep the compact statement. Delta U equals Q plus W, remembering W equals minus P delta V for expansion or compression work at constant external pressure. Let's visualize with a simple piston cylinder model of a system. The gas is our system inside the chamber. The piston can move up or down. Heat flowing in will be shown by a red arrow into the system. Work during expansion will be shown by a green arrow pushing the surroundings. But in this CBSE convention, it counts as negative W for the system. Let's connect the picture to the equation. The core statement we will use is delta U equals Q plus W. For pressure volume, work only W equals minus P times delta V. So during expansion, delta V is positive, W is negative, and heat added raises internal energy. Now, a quick worked example with easy numbers. Suppose in one step, the system absorbs heat of plus 500 joules. And it expands against a constant external pressure of 100 kilopascal with a volume increase of 2 millicubic meters. We will compute W equals minus P times delta V, and then delta U equals Q plus W. First, imagine the piston lifting as heat flows in. Compute the work. W equals minus P times delta V equals minus 100,000 Pascal times 0.002 cubic meters equals minus 200 joules. And then delta U equals Q plus W equals 500 plus negative 200 equals plus 300 joules. Positive change in internal energy. Quick note on compression. If surroundings do work on the system, the piston moves down, delta V is negative, and W is positive in this convention. Heat removed would be negative Q. The equation delta U equals Q plus W remains valid in all cases. Summary. First Law of Thermodynamics for CBSE and NIOS. Delta U equals Q plus W. With only pressure volume work. W equals minus P times delta V. Use the sign convention. Positive Q for heat absorbed, positive W for work done on the system.